I finished with the recapping and now I want to do the resistance check, but I quickly found out that before I can do this test, I have to put the tubes back in, which I had removed so I could clean the chassis. Well, while doing so, I discovered that some of the tubes were not right. I discovered two 6 BC5s in here, and because I just took out all the tubes at once, I don't recall exactly which sockets these were in. But I can tell you what's missing after putting the others back in, which is two 6AG5s and a 6BA6. Go down here. And the third tube was a 6AU6. 6AU6 can kind of work as a 6AG5, so that might have been one of these over here. I really am not that familiar with the 6BC5. Maybe it's also similar to a 6AG5, but that doesn't explain about the 6BA6. So, I don't know. Regardless, I'll dig up replacements for those three, and I should really go ahead and test all the other tubes while I'm at it. Something else I discovered while cleaning the chassis is that the top of this coil had come loose. I'm really glad it didn't fall off or get broken or lost over the years. It's a rather large ferrite slug inside there. You can adjust it up and down on this threaded shaft. There's also two more of them here and here. What those are used for is to trap or absorb certain frequencies. The way that works is there's a coil of wire here, capacitor, and parallel with it, and you can adjust the resonant frequency point with this slug. So no electrical connections, it just absorbs it right out of the signal. You may recall that there was a very similar trap arrangement in the Admiral 30A1 series sets I restored recently. Those looked a bit different though because there was an aluminum can shielding the inner details of the coils, but these are just exposed right out there for you to see. But unlike the Admiral, these do not have exposed megacapacitors. These are tubular ceramic capacitors. And this guy does actually have a shield. I just haven't reinstalled it yet. No cover over the top though, just a box around it. Alright, so I will test all these tubes, dig up the proper tubes for those three, and then get to those tests. I finished checking all the tubes and found quite a few that were either weak, had shorts, or in the case of this 1B3 high voltage rectifier, had an open filament. So I scrounged through my stash of tubes and found replacements for all the bad ones and repopulated all the sockets. Okay, all the resistances seemed reasonable, within, say, 20-30% of the stated values. So I've got my voltmeter hooked up to a key point, 275 volt supply point, and I'm going to try powering this setup for the first time since I first got the set, and just check to see if the tubes would light up, meaning the filament supply was good. And I checked the transformer secondaries with no load on them, and my voltages seemed okay. But some of the testing I've done. And so set this off. I'll plug into my Sencor PR57, which can do up to 3 amps continuous, which I think will be enough, but this set does draw quite a bit of power. Alright, here goes. Well, 349 volts. I should drop that. Dropping down. Whoa! Checking the current draw on this thing. Pulling a little less than 2 amps. Well, this voltage is actually down too low now. 230, 238. Yeah, Got his side of the speaker. Nothing on the CRT though. Alright. Well, at least I know I can turn it on and things will immediately blow up. I'm going to start checking some other key voltages. Like there's one point that should be minus 100 volts. And so once I'm satisfied that the key power supply voltages are alright, I'll flip this chassis down. The voltages I want to check are these guys. So that was 275, which is lower than it should be. I want to check these other points. Where are we at? Here, I want to check these voltages to make sure they're all more or less alright. Now the fact that that was down a bit low has me a little concerned. But obviously there's no dead short or anything. That's a good sign. So no glow on the CRT doesn't necessarily mean that there's no high voltage present. I don't know, like with the brightness, contrast, and the focus. I don't know how all that stuff is positioned right now. I'm checking which should be the highest potential point in the set, which is the filament on the 5U4 rectifiers. Should be 300 volts, I'm only getting 256. And likewise the minus 100 volt bus was only about minus 80. In other words, everything's low. Well, when I checked with my Syncor PR57 again, and although I set it for 115 volts output, with this heavy a load it's dropped all the way down to 105. So let's try cranking that up a little. And we're not quite at 300, but that's close enough for me. So, and nothing's gone up in smoke yet, so that's a good sign. So what I'm going to do now is flip this chassis down so I can get the controls in the CRT more easily. And let's see if we can get an image and maybe some sound out of this thing. Okay, I've got this right side up. Obviously, got the knobs reinstalled. And you can see the tubes more clearly now. I think that high voltage rectifier filament is glowing, which is a good sign. Yeah, it is, because that means there has to be power going through the flyback and it's oscillating. And the horizontal output tube isn't red plating or anything, so... Well, okay, maybe the 1B3 isn't. Well, it's hard to say. I'm seeing reflections from other tubes, but I think I see a faint glow way down in there. Don't get too close, so I don't want to shock myself. Obviously, get a high voltage probe and see what's going on with that. I think this is brightness, and this is horizontal and vertical hold, and this is contrast, I think. Volume, channel fine tuning. Alright, so here's channel plates. So 1, 2, 3, 4, 5, and I want to find channel 6 so we can get some sound. I think it's on channel 1 right now. So line up like that. 1, 2. Okay, that's odd. Even stranger because it's a different station. Look, I got an FM radio going. Well, those are definitely two different songs. This should be channel 6. They do more alternative modern rock, or whatever you want to call it. Not rap or hip hop, whatever that is. Okay, this could be channel 6. Huh. Obviously, I'll get a proper channel source hooked up so I can see what's going on. I'm pretty sure he just said 87.7, so this is indeed VHF channel 6, so seems like the receiver part of it's working alright. Nothing on any of the higher frequency channels. So why on channels 2 and 3 am I picking up FM radio, I wonder? It sounds really good. I don't know what exactly I'm receiving or why, but hey, it sounds alright. Okay, we'll grab a high voltage probe and kind of get under there, or maybe right on the high voltage cap in there and see if there's anything going on. Okay, let's see. Okay, there is high voltage, but man, it's barely deflecting my probe. It's looking like 2,000 volts maybe. Something's not right. All the DC voltages in the horizontal circuitry checked out okay, so now I'm checking waveforms. Right now I've got the scope on the cathode of the horizontal output tube, which should look like that, with 11.5 volts peak to peak. What have I got? Pretty much looks like it's supposed to. And 11.4 volts peak to peak. That's pretty darn close. Let's double check the frequency, which should be lower than that. Should be 15.75 kilohertz. I've got about 16 and change. So although the amplitude's right, the frequency's off. And that could account for it because it's supposed to be kind of a like a peak efficiency point at 15.75. I'm not sure what adjusts that in this particular set. Probably the synchro lock control. Let's see if I adjust that. What does that frequency? Oh yeah, it's definitely changing it. 17 now, so let's go the other way. Around 15.75. Not seem to be making much difference. I kind of thought if I adjusted that and got it closer in range, I might start hearing this, because usually you can kind of hear the high voltage circuitry because there's so much energy going through there and the high voltage, and kind of almost feel the high voltage in the air. But no, made no difference that I can see. So I will keep checking. Now I think all the components are good, and I even swapped out the high voltage rectifier just for the heck of it. I could try swapping out the horizontal output tube and damper tube as well, but before I do that I'll check some more voltages. Now the only other components I can think of to be bad down here is maybe a coil like that, which I think is the linearity, or that might be width. And there's also one up here. One of them's width and one of them's linearity. It's kind of tucked in up there. But either they were both open, or I don't think it would really affect things that much. They're just meant to kind of fine-tune the flyback, which leads me to the flyback could be bad. Not the end of the world, because these are fairly common because they were used in so many sets. In fact, I think the flyback in those Admiral 30A1 sets have been restoring. I think those are compatible, and I do have a couple spares. But let's not ponder that quite yet. Which leads me to one component that I've heard is fairly suspect, or prone to fail in these sets, which is the mica caps. Got 1, 2, 3 of them. However, the horizontal oscillator is running at the right frequency now, and the waveform looks right, so I don't see what impact those mica caps would really have. So this is on the cathode of the horizontal output tube, which means that it's getting a drive signal, and there's current going through it, and this is the drop on the cathode bias resistor, which is here. So the drive on this is probably on. Let's see what happens when I adjust that drive. I didn't think it was having any effect when I was measuring the high voltage. Let's see the I think it's increasing the voltage a little bit. So now it's about 12.7. Now it's 11.7. Yeah, so it is adjusting the drive to the tube a little bit. So why don't we have any high voltage? Also, since I couldn't find any problems underneath the chassis, I'm back to working on the top side. I just removed the screws holding in the side of the high voltage cage, and I swung it out of place. I can't remove it entirely because there's a high voltage lead going through a hole here. And the way to get this out is to disconnect the end, which I don't want to deal with right now. So I'd already taken this out and cleaned it out earlier, and went over and did resistance checks on things. For example, I know this resistor is okay, or at least it was before. I think it still is. And I checked the flyback, and I checked underneath here, which I'm going to double check now again. The filament for the high voltage rectifier pulls its power from a couple loops, or maybe just one loop of wire around this core. It's these two wires running here. And underneath here, there's actually a 3.3 ohm resistor buried down in there. I believe that's to limit the current flow, so doesn't burn out the filament if there's a surge. Well, that may have gone bad. Something else I noticed though is over here, there's a mecha capacitor. I could not find it on the schematic anywhere, and I went through the wiring diagram and it's just not there. It turns out it's connected between pins 1 and 4 on the flyback. So that would be between this node running down here to the linearity control and this 275 volt bus. It's just not here. One thought that occurred to me is that it may have been there to expand the width. I've seen aftermarket mods. Usually it's something that like fits in under the damper tube, I think, which puts a capacitor in the circuit in such a way that it will increase the width. Otherwise, I don't know. Maybe it's a later modification, or maybe it was added on. Can't quite tell if it's original or not. I'm just looking at the solder joints. I don't know. But I can certainly take it out, see if it makes any difference, and while it's out I can test it. And I'll certainly go back through and double check all the resistance tests. They show you the values here on the schematic. I already checked the easiest one, which is just measuring the resistance between the plate cap on the rectifier and the output tube, and I do get about 240 ohms, so at least I know that part is good. And there's that 3.3 ohm resistor I was talking about. Oh, another possibility too is that high voltage cap could be bad. That would definitely decrease the high voltage. Oh, and that 1 meg resistor there too. I know I checked them earlier, but weird things can happen when you're dealing with high voltages. High voltage cap, that's an oddball one. It's sitting up here on top. Probably wouldn't be too difficult to disconnect it. That's just a clip-on lead there, and I do have a bunch of possible replacements. Things I've saved and scavenged over the years. These are high voltage rectifiers, but down in here, let's see. 500 picofarad. I should have brought the voltage rating, but I think this is the same type. Should be 500 picofarad rated for 10,000 volts or better. This is double the capacitance. Voltage rating's okay. This guy would work for sure. 20,000 volts, 500 picofarads. It's just a matter of how would this mount in there. The tough things to test. Because typically you don't have a type of meter that can measure breakdown voltages and leakage currents up to 10,000 volts. On the other hand, they rarely fail. In fact, I don't think I've ever found a bad one, but this is the oldest set I've worked on, so I'd say anything's fair game at this point. Some of you may recall that I actually have another 630 TS, so let's take a look and see what it has down in here. Well, there's no mica cap. On the other side it was connected between these 2 points. But we do have this guy, which I'm virtually certain is not original. So, well, I don't know how much that really helps. I mean, it confirms my suspicion that there probably shouldn't be a mica cap here, but I don't know what this is all about. At least while I'm down here, I'm going to rob some of these tubes. I can swipe them out in the other set. Because the 6BG6 in the other set, the top cap is a little bit loose. Removing that mica cap and swapping out the tubes had no effect, so now I'm trying to replace the high voltage cap. And I've been trying to pull it off from the top and wasn't having any luck. I disconnected the high voltage lead and it's kind of wobbling around here, and it seems like it's on a spring or something. You pull it and it doesn't want to come out. So I checked underneath, and yeah, it actually is spring mounted. And it's held in by one of those speed nut things where you press it on and it doesn't want to come off. It's like spring steel with little bent teeth, so I'm going to somehow pop this thing off and then I can try replacing it. I'm making some progress. For one, I got an explanation for where this radio station's coming from a guy on Video Karma. He said, well, if you've got a strong FM station in the area and the difference between your audio IF or a multiple thereof and the TV channel you're tuned to, you might just pick it up. So I've heard a station enough to hear the station ID, and it's 107.9 FM. The audio IF is 21.5, so if you double that up and subtract it from 107.9, you get right about the audio carrier of channel 3. So that seems like a pretty darn good theory as to why I'm picking that up. 2, I did replace the high voltage rectifier. I went with 1000 picofarad 12.5 kV cap, just because it fits in there really nice. I think it helped a little bit. High voltage is up to around 5,500 now, which seemed to me should be enough to get something on the face of the CRT, even though it should really be about 9,000 to get a nice bright picture. Then something occurred to me that I've been tripped up by before, which is that the focus coil and the ion trap can really screw up these test CRTs, because they're auto-focusing and they have a straight gun, and they don't need an ion trap. But by having the ion trap magnet on there, it's actually is deflecting the electrons away from the screen. So normally the gun would be bent, and this magnet bends them back so that they go straight. Well, this is already straight, so having the magnet there bends them so they shoot out the side. So I took it off. Now, this being an electromagnet type, it has to be installed as part of the power supply. So I just kind of carefully put it off to the side and slated it with a little bit of foam here. And 2, there's the focus electromagnet. So what it is, made sure the brightness was cranked all the way up, and then I reached around and adjusted the focus control. I'd like to disconnect that entirely, get out of the way, but that is, again, not so easy to do. But by adjusting the focus, which is this big rheostat here, hey, a trace. Unfortunately, no vertical deflections. I think the vertical oscillator might not be right, or vertical output transformer, or vertical output amplifier, or something. But hey, it's something glowing on the face of this CRT, which is a good thing. So what could the remaining issues be? So I just mentioned about the vertical issues. High voltage still low. Well, of course, there's still a flyback, which could be a culprit. One of those mica caps I mentioned earlier. And even though I tested the resistors underneath that high voltage socket and they measured okay, I think I'm just going to go ahead and replace them anyways. I don't care about being authentic. Nobody can see them down there. I'll use metal film caps. Doesn't matter. Because that 1B3 rectifier, although it's definitely glowing, it's rectifying, it's not glowing as bright as I've seen them before. You can barely even tell there's any filament glow there whatsoever. So, I don't know. I just suspect that either the 3.3 ohm resistor is limiting the current, or that there's not enough energy as there should be going to this flyback, which leads me to one other thing I want to experiment with, at least for now, is these two resistors here. They put them in parallel, I guess, because the value they needed wasn't standard. Either that or they couldn't get the wattage rating, because these are each 2 watts. Maybe they needed a 4 or 5 watt resistor of around 18 or 19K, and they just couldn't find them, because I think if you put those two in parallel, well, actually no, you need a little more than that. Be around 12.5, 13K, something like that. Anyways, when I measured those, they're high by 20% maybe, which might be enough to throw the biasing off a bit on this tube and decrease the power going through the flyback. I don't know. It's easy enough to experiment with, anyways. Things are looking better. I had a hunch, before I checked anything else, why not swap out the vertical oscillator tube? And I recalled that when I tested it, it was good, but just barely into the good range, and I was having a hard time finding any other 6J5s with the metal type, so I just left it in there. But then I remember, well, wait a minute, I got another 630 TS, so why don't I just pop the tube out of that one and stick it in here? And I did, and now I've got vertical deflection. Sure, it's dim, but we already know we got low high voltage, but hey, there's something. Let's see if I can get the focus any better. Alright, first off, let's get to an actual broadcast station. There's something that looks sort of like a video signal.
Chicago style is old style. It's history, wrapped in tradition, coated with nostalgia, and then served cold, like freezing cold, which only makes the summer that much more enjoyable.
Adjusting the focus now, and if I go anything except to one extreme, the picture really fades away, so that's definitely having a detrimental effect on the image. Adjusting the hold controls now. It's got to be vertical. Horizontal. Not quite, but I know I was mucking around with that synchro lock control in the back, so I better fiddle with that. Yes, no. Maybe. I think I just hit it for a second. YouTube's not going to like this, so I'm going to turn the volume down. I just switched to a stronger signal source, so see if that makes any difference. That's got to be it.
Chicago.
Well, that's still that radio station. Well, that could be the TV station just coming through. Try switching the output in the source to 4. I think. Yeah, it's on 4 now. Probably there. Yeah, looks like I'm just having some major issues trying to lock on horizontally. Now this is where those bad mica caps could definitely be playing a factor. I mean, I've been warned by numerous guys that those mica caps in the early RCA 621 and 630, 721, just replace them. And those are definitely involved with the synchronization circuits. So that's about as good as I can get it. Which isn't saying much. That's got to be it. It sounds like a vintage TV show.
General, turn to the right. That's it. Good. Now to the left.
Get a feeling the alignment's way off on this set too. Oh, there we go. It's adjusted contrast control. If it's like most sets, the contrast has a huge impact on the AGC. And horizontal sync seems to be a lot better now. I can rotate the control through its whole range and it stays locked. So maybe those mica caps are okay after all. There's height control. Alright, so promising for sure.